This week in AI research. Papers actually worth your time, each with a straight read, skim, or skip. Let's count them down. Number 7. 2 billion parameter open speech model just set a new state-of-the-art on multilingual text-to-speech. This paper takes on TTS, turning written text into natural human-sounding voice. Most strong models drift over long passages and lean on closed weights, so you can't run or fine-tune them yourself. Dots.tts makes a different bet. Model speech in a continuous latent space, condition on the full history to stop the drift, then self-correct after training. No reward model needed. The result, best average scores on seed TTS eval, low word error rates, strong voice cloning, and 54 millisecond streaming latency, with code and checkpoints open under Apache 2.0. For anyone building voice agents or audiobooks, this is one you can actually ship on. Verdict, read. Number 6. Unsmall linear filter makes a language model a better, smaller embedding model for free. This paper takes on text embeddings, the vectors that power search and retrieval. Big language models make surprisingly weak embedders. Turns out their vectors get hijacked by common meaningless words, drowning out the actual meaning. The team found that filter living right inside the model, the UnEmbedding matrix. Strip out that high-frequency subspace, and the embedding clears up. A one-shot linear transform they call embed filter. The payoff, better zero-shot retrieval at a smaller dimension, so your index is cheaper and search is faster. No retraining at all. If you run a retrieval stack on open LLMs, this is a near-free upgrade with code today. Verdict, read. Number 5. Video world models keep forgetting where things are. This one remembers and it runs faster doing it. This paper is about video world models, AIs that generate a consistent explorable world one frame at a time. The hard part is spatial memory. Keep the room behind you the same when you turn around and look back. Most methods rebuild the 3D scene in pixel space, which is slow and eats memory. Their bet, store that 3D scene information directly inside the diffusion model's latent space and skip the pixel space reconstruction entirely. The world stays spatially consistent and generation gets faster while using less memory. For anyone building world models or interactive video, that's a cleaner, cheaper foundation to build on. Verdict, read. Number 4. What if your AI didn't wait for you to find the bugs? It went looking for the problems you hadn't noticed yet. This is about agents that read documents and code, then surface issues on their own. Most agents are reactive. They answer the question you asked. They don't go digging for the hidden problems buried in a long document or a sprawling codebase. Tide flips that. It uses reusable thought templates and an iterative loop to proactively discover multiple hidden problems from context, then works toward resolving them across both documents and code. For building review or QA agents, that's a shift from answering questions to actively finding what's wrong. Verdict, read. Number 3 is one model that understands and generates the physical world across video, images, and language at once. This is a world model, an AI that learns how the physical world behaves for robots and self-driving cars. Most systems bolt together separate models for seeing, reading, and predicting, which fragments how they reason about reality. Cosmos 3 folds it all into a single mixture of transformers, one omnimodal model that hits state-of-the-art on both understanding and generation. For anyone building physical AI, that's one foundation to start from instead of a stack of specialists you have to glue together. It comes from NVIDIA. Verdict, read. Number 2. Imagine never fine-tuning your code model for a new repo again. A network just generates the adapter for you. This is about code language models, the AIs behind your autocomplete and your coding agents. To make one good on your specific code base, you normally train a custom adapter. It's slow, and it goes stale every time the code changes. Code to LoRa trains a hypernetwork that reads a repository and generates its LoRa adapter directly, no per repo training run. And it keeps up as the codebase evolves. For teams building code assistants, that's cheap. Instant per repo specialization that doesn't rot the moment someone merges a pull request. Verdict, read. Number 1. Mistake. Before a coding agent can fix a bug, it has to find the right code, and a new benchmark shows that's where the real skill hides. This paper is about coding agents, the AIs that navigate an entire repository to make a change. Most systems still lean on plain retrieval, search for keywords, grab the top matches, and hope the files that matter are in there. But real code bases are tangled, and the right code often doesn't look anything like the query. SWE-Explore tests something different. It asks an agent to actively explore the repo and return a ranked list of the code regions that matter, all within a strict line budget. And that agentic exploration beat traditional retrieval, surfacing relevant code that keyword search missed. For anyone building coding agents, the takeaway is clear. Let the agent explore, don't just retrieve. Verdict, read. That's the research worth your week. A fresh cut of the best papers drops every week. Subscribe so you never miss the one that changes how you build.